All right, so let's get into our second lecture. This one is going to cover section views or sectional views. This is going to build off of what we talked about with the first lecture, orthographic projection. Section views are basically a type of orthographic projection or a modification of an orthographic projection. All right, so let's get started. So just as an overview, we're going to talk about the purpose of section views, what their intention is or what they're intended to do, and that is to show interior details clearly. Oftentimes in models, they don't even have to be complex shapes, but in models there are internal details, holes and cutouts and openings or spaces or any other geometry like that that we need to show clearly in an orthographic view for either a descriptive purpose or to dimension those details, and section views allow us to get into the object to show these interior details. One of the ingredients that that we need with a section view is a cutting plane line, and the cutting plane line is going to show you where the object, or show where the object is cut to obtain the section view or to make the section view. Once we cut the object, we're going to show the area that was cut by using section lines. And so these section lines are intended to show where solid material was cut, and they are to be shown in a certain orientation with a certain style of line. We'll look at these. Section views may replace standard views, all right? And finally, we're going to talk about conventional practices, or basically different rules and guidelines for using section views, because many times we're able to, or we need to adjust how our orthographic views look to make the section views make sense. And in order to do this, we have to kind of break the normal rules for creating orthographic views, okay? And we'll talk about all that stuff. So let's first start with a full section, okay? So a full section view, as you can see in this image right here, a full section view is when we cut an object completely in two, okay? So you can see the cutting plane here is identified by the blue plane, and it's going through the object, right down the center of the object, splitting it into two halves. All right. After our cut, you can see the object separating the left and the right half in this case, and on the left half, you can see the section lines which show where solid material was cut. Okay, so clearly this was a rather complex part, right? And so the section view is going to allow us to see the internal details. Now, obviously, or maybe not obviously, this is a isometric view, or what we'll call it a three-dimensional view of our object, as is this description or display of the section view and how the section view is created. What we would actually see on the drawing is something like this. Now, this is an interesting drawing, and let me describe it. So first of all, it is exactly the drawing that we just had here. All right, it's the same part. This view, the front view, we'll call it the front view. The front view shows where the cutting plane is, right? And that's shown with what's called the cutting plane line. Okay, so the cutting plane line travels right through the center of the object. It basically separates the left and the right half. Okay, and then we show the section view on the right-hand side. Okay, now in conjunction with the section view on the right-hand side, we have the arrows pointing to the left. Okay, the arrows indicate the direction of sight. And so to create a right side section view, I need to cut the object here, remove this half of the object, and view it from this direction. Okay? And that's why the arrows point to the left, because they indicate the direction of viewing or the direction of sight for the section view. Okay. Now here you can see all the complex shapes in here. We have some highly complex holes, with cutouts and all that good stuff. You got a real complex section on the lower hole, which is different than the other ones over here. And these lines are just intended to show you the projection of these. These are not lines that would actually be on the drawing. But what is also interesting is on the left-hand side, they show you what the view, in this case the left side view, would look like without a section view. All right, and so you can see the hodgepodge and chaos of hidden lines here. And the hidden lines here really make it difficult to understand what is going on inside of this object. And so these hidden lines are the perfect reason why we need to make a section view and to show the full section as it's shown in the right side view over here. Okay, so this is no section view, section view. All right, so that's a full section cutting all the way through a part, creating two halves, so to speak. As I said, cutting point line may be omitted because it's understood to be through the center. So oftentimes with full sections, we omit the cutting point line because it's obvious, especially in the case of a single section view in the drawing. Okay, we can omit the cutting point line, replace it in this case with a center line. And then finally, this usually replaces the standard view as it does here. We would not show the right side view. We would replace the right side view with this right side section view. All right, just a couple more of examples of a full section. So here we have kind of an open box, right? So the cutting plane separates the box into two halves. Here we have a top view of the box and a front view of the box, and these are the standard views, so no section, no cutting plane. So the cutting plane, as we can see here, is going to cut right through the center right there, and so we're going to recreate the front view here with a view. All right, there's our cut, and you can see the two halves are separated. Notice where we're cutting through material here. We don't cut through the holes, right? And that's going to generate this for our section view, and our top view is changed by adding a cutting plane line. Okay. All right, let's look at some more examples. Here we have, this is very similar to what I just showed you. Cutting plane separating the object in half. Here you can see the cutting plane line is in the top view, generating a front view section, front view full section. We don't have to have the cutting plane line in the top view. Obviously, we could have it in any view we want or need it in. So in this case, we have a front view with a cutting plane line here, which generates a top view with a full section. Now, of note here, notice the gap in between this cylindrical feature. So there's no material here. So as the cutting point line passes through this, it's not cutting through material. So that's why there's no section lines here. Likewise here, this is a slot, an open slot. There's no material, and so there's no section lines here. The only place we're cutting through material is right here, and that's why there's section lines right here. Okay. And then this is just an example of how you might need to show or want to show two section views in a single drawing. So this would be an example of when you do need to label your section views, your cutting plane line, so to speak, with AA in this case and BB. So we have section view AA and section view BB. Notice that BB is kind of around the corner here, so to speak, right? So it's a right side section view, but it's developed normally from the front view section. Obviously, alternately, it could be placed up here, but you would have to rotate it 90 degrees counterclockwise, and then of course make sure it's aligned. Section views are aligned the same way that orthographic views are aligned. All right, so let's talk a little bit about the cutting plane line. So this is how the cutting plane line is supposed to look. It's either large dashes, or it's an alternating long with two short dashes, long with two short dashes. With CAD now, you know, this image or these dimensions were really taken from when we would do hand drawings and you would actually be measuring some of this stuff out. With CAD, we don't really worry so much about the exact spacing on this. We let CAD do it, although we can adjust the spacing in some cases, and you'll see in some of the demos that I do where you can adjust the spacing in Fusion. AutoCAD, likewise, you can adjust the spacing, but for the most part, we don't mess with this anymore. We just make it look good. Okay, but you will note that the cutting point line is a thick dark line. All right, a thick dark line. All right, and as I mentioned before, in some cases the cutting point line can be omitted where it's obvious. All right, when there's only one section view or one cutting point line that's used and where it's obvious. Hatch patterns have developed over the years. We used to have different hatch patterns for different materials. So if you were making something out of steel, this would be a hatch pattern. This would be bronze or brass. This is, you know, zinc. Here's magnesium and aluminum. We don't do that anymore. All right, we do not do that anymore. Now the standard or the rule for hatch patterns is all hatch patterns are this format, right? Just a uniform lines spaced evenly. All right, there are some rules for how section lines, or as they're called in AutoCAD, hatch lines or hatching lines, can be shown. So in the middle image, we want to avoid section lines that closely run maybe nearly parallel or parallel to object lines. So here's an object line, here's a section lines. We want to avoid that. So we want to rotate the section line in this case, okay? Likewise, we want to avoid running perpendicular. So in the first object on the left-hand side, you see a better layout for section lines, all right? The hatching is never bounded by a hidden line, so there's no hidden lines. We don't, generally speaking, hidden lines are to be avoided or left out, omitted from section lines or from section views. Adjacent areas divided by a visible line in a section view never can both contain hatching. So what that means is here, this open space here is not going to be hatched, all right, or is not going to have a section view. The reason being is because this is a hole or an opening. Same here and here and here, okay? A hatching or section line should not run parallel or perpendicular to a major feature, so we've already talked about that. All right. Dimensioning, oftentimes the purpose of section views is to display a detail so that we can dimension it in our drawings. Sometimes the best way to dimension a section view is obviously to pull the dimension outside of the section, outside of the section lines. All right. That's not always possible. So when you have to dimension inside of this, you want to break out the section lines around the number so it's clear to see. This is very difficult to read. Okay, so we want to avoid this. By the way, Fusion will not do this for you. So you really, it won't do this. All right, so you really have to pull it out with Fusion. AutoCAD, of course, there are ways to get the hatching, in the case of AutoCAD, around the number. All right, so I already mentioned that hidden lines are to be omitted in section views. There are, strictly speaking, there are some cases where we can use hidden lines in a section view. That's rare, and you really should try to avoid as much as possible using hidden lines in a section view, okay? Generally, it's for very, very special cases. So in this case, the hidden line is intended to show this back surface right here. It's debatable whether this is required, whether this is necessary. You know, I suppose the thing with hidden lines is you're not allowed to dimension to them. So you're showing this, but it's not clear what the dimensions of it are, so we can't dimension to it. And so you really need another view here. You might want to make another section view cutting through that to show this curvature here. You know, that's a difficult thing. I would still avoid doing that because you're going to do this and then you're not going to be able to dimension it. So you have to figure out how you're going to dimension it. So again, this is probably not a good example. Likewise over here, they're trying to show this boss for the hole on the back surface, right? Full section. So on the back surface there. Again, I don't think this is necessary. So this is an example where I kind of, you know, I put this in here so that we could talk about it. I don't think this is appropriate. How would I get around this? Again, we can't dimension it, so it's just there. How would I get around this? I would show a left side view also. Maybe even a partial left view where I'm only looking at this object, the boss, right? Or the hole. Okay. So next we're moving on to, we'll look at the different types of section view. So full section is one type of view. Another type of section view is a half section, okay? And as we can see in this graphic, a half section view is when you take out a half of a, or in this case, a quarter, but half of an object, right? So we open up this section right here and remove it. And then we draw what we see here. So it's a little bit hard to understand what we're drawing in this graphic. So let's look in this view. So here's the regular view, right? And you can see clearly that we have a hole here that remains hidden. So if we want to expose that hole or expose the wall thickness on this pipe, then we could put a cutting point line, and notice for the half section, the cutting point line starts here and we have the arrow on that side as normal. It comes out, comes through the middle, and then it takes a 90-degree turn and it comes out towards where the section view is going to be placed. Notice also there is no arrow on this side of the line. You will actually see textbooks and other images on the internet that are wrong. All right, there is no arrow on this side. There is only one arrow in a half section. True story. At MIT, Massachusetts Institute of Technology, world-renowned engineering university, they have up on their website wrong images of half sections with an arrow pointing here. That is completely wrong. In the standard for section views, that is the rule book for section views as developed by the American Society of Mechanical Engineers, they clearly state that this only has one arrow. Okay, so this is correct. What you see on MIT is wrong. Right? Another thing of note is that notice that this line, even though the cutting point line comes out here directly halfway through the object, we do not show a visible line here. All right, you don't draw a visible line here. We put a center line because that's the middle of this cylindrical region right here. So it's a center line. All right, no visible line right here. Interestingly enough, Fusion insists on drawing a visible line here. So this is another case where Fusion is clearly wrong. All right, Fusion does this incorrectly. Broken out sections. Here we have, it's a broken out section is a way to break out a specific area to show the internal detail. So here we have a little pilot hole that we just need to show in a section view. We don't want to create a section view for the whole thing. All right. So we break it out here. The break line that divides the sectioned part with the unsectioned part is a visible line that is drawn roughly like this. And there is no cutting plane line over here. None. Also, Fusion cannot create broken out sections. All right. So on to our, let's see, full section, half section, broken out section. So now we're on to our fourth type of section view. And this is a revolve section. And a revolve section is done by creating a cutting plane that slices through the object, and then taking that section view out and putting it back in the view of the object. All right. So it's a way to, if you look on C is the finished object, the finished view. It's a way to kind of combine two views. So we have a long view of the rod, in this case the bar, and then we have a section view superimposed on top of it. Notice a couple things. We have a center line going through here indicating the center of this section. And B, we do not have a cutting plane line. So again, this is the second drawing that does not need a cutting plane line. All right. And again, Fusion 360 cannot create this type of drawing. Here's some examples of revolve sections, because you're probably wondering, when on earth would I want to use this? So in this example, we have a rather complicated cross section where we have horizontal and vertical ribs coming in here, joining these two cylindrical portions, right? And that may be difficult to show in a drawing, or to dimension in a drawing. So we want to expose that area. And so one way to show that, this is just a dramatization of where the cutting plane line is, right? We don't need the cutting plane line here, but we're cutting right through there, and then we can put the section right where it's cut, basically. So this transfers straight down, and then we rotate that and put it right into position. Oftentimes you want to separate the section view, the revolve section, with the actual visible edges of the object. And so what you do is you break around that to show the revolve section and the broken remainder of the view. All right, related to the revolve section is a removed section, okay? And a removed section, well, think of it this way. In a revolve section, we're cutting and we're rotating and moving or putting the section view right back into the view of the object. A remove section is where we do the same thing, but instead of putting the section view right in the middle of the object again, we remove it to some other place in the drawing. Okay. Now the benefit here is we can move these views anywhere because they're labeled A, B, B, C, C. We can move them on the left-hand side over here. We could even move them to other drawings. Okay. So, and notice here we can kind of stack these up. So we're cutting through here, we're cutting through here, and we're cutting through here in the different areas of this crank rod. Okay. And we show these sections. And the nice thing is here, it's very easy, convenient to dimension this, right? So we're not messing up this drawing with a whole lot of dimensions and some views and stuff that make it hard to read. We can put them right here and dimension them. And once again, Fusion 360 cannot create remove sections. Okay. Fusion 360 has some issues with section views. Offset sections. All right. So offset sections, and it's probably easier to look on the right-hand side over here in the top view. An offset section is used when we have features that we want to cut through, but they don't all lie in the same line. Right? So here we want to cut through the hole here. We want to cut through this slot. We want to cut through this hole and then this hole. So we can't have one cutting point line that goes through all that stuff unless we cut, turn, cut, turn, cut, turn, cut. Okay? Notice that each one of these turns is at 90 degrees, right? So we're not making angles, right? We have to cut through 90 degrees. Notice, this is very important, that at no point do we see this bend down here. Likewise, this one is not shown here, and this is not shown here. So this is one of those areas where, we're technically speaking, we might be breaking the rules of orthographic projection, but it would be confusing if we put lines in the middle of the section lines right there, vertical lines in this case right there. So we don't do that. So in truth, this section view, this offset section front view, gives a misleading or distorted view of the actual object if we just use this view. But when you look at the top view, you can see clearly that these features are not in alignment, they're shifted, and this is an offset section. I will also note, and again, I disagree with this. This is taken out of a textbook, by the way. I disagree with the need for these hidden lines back here. All right, I would say do not use these hidden lines. All right, because they don't really add anything. They just mess up the detail here. I would say that we would need another view to show the detail for this hole with the boss. All right, and again, Fusion 360 can make an offset section, but what happens is it insists in drawing a line where we make the turn. So there would be a line here from this, and then a line here from this. Okay. Here's another example of 3 offset sections built in a row. And what's nice about this is you can see in this front view that there's different levels of detail. So we have at AA, we have kind of right against this wall, we have 2 holes with a little boss pad here and a boss pad here, right? And so cutting point line AA goes through here and then makes a little jog and then goes through here. And then we show that here, section AA. And then we want to cut through this detail. So we cut through this hole, jog over, cut through this larger hole, jog over, cut through this cylinder and hole. All right. And then this is section BB. And you can see the detail right there. Notice that in section BB, we do not show the hidden lines for section AA. Right? By the way, these hidden lines represent threads. So this is a tapped hole. And then finally, CC, same thing. We have this horizontal hole right here. Horizontal. Well, vertical, but I'm thinking that this is probably the bottom. That's why I called this horizontal. Tapped hole, tapped blind hole. This is a tapped blind hole too. It doesn't go all the way through. And then we have the cutting point line cutting through here, jogging over, cutting through here, and then jogging back. So this is a very nice and convenient way to stack up our views. So we have a front view and a series of right side section views, AA, BB, CC, and we've used section view or offset sections to kind of show each area. Okay, a couple of the rules for creating section views. First thing is we do not section thin ribs. So in this example, you can see cutting point line AA, we're slicing through the cylinder, and then we go through a thin rib right here, or thin web, and then through the base. Because if we did this normally we're obviously cutting through material, and so it would be, we would show it like this, okay, where it's all sectioned. That gives a misleading interpretation of the object as being fully solid. So we don't do this, and instead we opt to not include the section lines in the thin web or thin rib. So this is how we show it. All right, align sections. All right, so in cases where the cutting point line is not parallel to the plane of projection, right? So understand that in this view over here, there's a plane of projection that basically runs vertically in between these two views. This cutting point line is not parallel to this plane of projection. So what we do, even though we show the cutting point line just like this, it's kind of like an offset aligned section. So this is kind of complicated. offset, we jog over here, and then we come at an angle through this to cut through this hole and these pair of holes, really. We draw the section view as if these features were rotated parallel to the plane of projection and then projected across. Okay, so surprisingly enough, Fusion 360 does do this, as you'll see in one of the examples that I do in the video for section views. Okay, I think the second video number 2. All right, so surprisingly enough, Fusion 360 does this, right? What we do not change the view where the cutting point line is. So we don't actually rotate these features over here and leave them over here. We just draw the section view as if these objects were rotated and then projected across. Here's some more examples of the same thing. Notice on the far right hand side, this is incorrect, right? Even though this is a true projection in the sense that, hey, there's no hole there, so why am I going to draw a hole right there? Well, because it's misleading. And so this is what I was talking about, where we get to kind of adjust or manipulate the rules for orthographic projection with section views. So again, because our cutting point line is not parallel to the plane of projection right here, we get to rotate this feature as if, or in parallel to the plane of projection and project. All right, so this is correct. This is incorrect. Some more examples. This is combining thin ribs with aligned sections. Okay, so here we have an aligned section cutting through here, but we have a thin rib and a thin rib here. So we cut through that, we do not section that, we do not section that. Here, another aligned section, but notice that we're cutting through the thin rib in a different manner. We're cutting through, not separating the sandwich, so to speak. You know, if this rib was a sandwich, separating the two halves of bread, we're cutting right through the middle of the sandwich. Okay. I hope you're not hungry with that analogy. All right, so this is just more of the same. A couple of things to note here. So first of all, this is a complex part. So let's understand we have a ring here, we have 3 ribs or spokes, and then we have a central hub. And the central hub has a keyway in it right here. Okay, so the cutting point line comes down from the top, from due north. It cuts through this hole, and then it's going to come over here at some, radius, and then it's going to cut through the rib and cut through the keyway, and then travel down straight due south through the rib, and then it's going to make another turn at a radius and then cut through here. This is the true projection, right? This is wrong. I think you can clearly see this is just a mess. This view, in fact, doesn't really explain anything. It's actually more of a hindrance and more confusing than anything. This is the correct view. All right, so let's take it in stages, right? First of all, the hole, nothing wrong there. We project it over. This rib, it's not parallel to the plane of projection. So we draw in the section view as if this rib is rotated here and it's lined up north to south. Same thing for the keyway. The keyway is drawn in the section view as if this is rotated and right there. Rib, nothing wrong there. We project that, and then this hole is rotated around here and projected across. Now, I will say this. So this is the correct view, right? But let me also say this, and I'm sure that you've already seen the red line here. This is a horrific cutting point line, right? How would this actual cutting point line be drawn? Well, what you would do for this, according to the standard, is you would draw a cutting point line from north to south, straight through. You do not have to have a cutting point line that cuts through each feature, right? If the cutting point line is a straight full section cutting point line, vertical from north to south, we still need to rotate this rib, need to rotate the keyway, and need to rotate this hole, okay? So the cutting point line, this cutting point line is a horror show. We would never, ever, ever do this. I hope that they're just showing it for descriptive purposes to show exactly how the cuts are made to generate this view. Okay. Also, suffice it to say, none of the parts that you're going to be working on involves this kind of construction. And last but not least, just to finish up, just a quick look at conventional breaks. The term conventional breaks is usually used to indicate we have a long part that we want to kind of shorten for the drawing purposes. So maybe this round solid bar is very long, and it makes no sense to make the whole thing in a drawing, so we can cut out the middle section, shove these two halves together, and then show it or dimension it that way. But when we do that, we want to break the object. So this is a conventional break for a round solid bar. Okay. If the bar is tubular, then we're going to add this little detail in here to kind of show that there's an opening in here because it's a tube. Rectangular, right? So these are both cylindrical. You can see that with the center line going through here. This is a rectangular bar or rectangular piece of material. And so we use a break line through here, just a ref line drawn on the visible layer. Here's round tubular, and then this would be wood. Okay, so that concludes the section view lecture. Please make sure you go through this. There is a lot of material in the midterm on section views. Okay, so in the study guide that I have for the midterm, there's some images that you're going to make sure you understand the different types of section views. Okay, you need to understand the rules for section views, in addition to the conventional practices for section views. Okay, that's very important. There is a substantial portion of the midterm that is devoted to section views. Okay, all right, so that's it. I'll see you in the next video.